By the end of this video, you should have a better understanding of an unpremult premult workflow and why it is important, as well as how you can maximize your use of the channel merge node, as well as any other circumstances where maybe you want to copy a channel over from another node. And we're going to briefly go over some of the merge operations that I find myself using the most. So let's get right into it. Starting in Nuke here, you can see I don't have a viewer, so I'm just going to click 1 to make sure that happens. By default, you will always have a viewer, so there's nothing to worry about here. I did not tell you in my last video that actually the biggest shortcut and hotkey that you will be using of all time is Control S. So let's make sure to save this project as test.nuke because we need to. That saved as test_nuke.nuke, but it is what it is. Okay, we got what we needed to come for. So I'm going to kind of run through the channel merge node, why it's important, as well as the copy node. The copy node is something that I find myself using probably more frequently than I even need to. Biggest circumstance that I find myself honestly using it for is just setting my setting my roto, right? So it's typically the first node in my tree involving roto, because I like to have my roto just set aside on its own, setting my format to no clip, which again, you're gonna have to be mindful of your bounding box if you do this, but it keeps some problems from happening. So I'm a big fan. Essentially what it's doing, just drawing this stupid little mask, this is the mask that we have created, right? So this is what's in our roto node, and our constant here has no alpha. It is only RGB, no alpha, completely zero, zip, as you can see by the bottom there. So the copy node, as you would expect, copies the channel from whatever is being plugged into the A pipe of it. So you can actually copy multiple different channels, up to 4. You could copy the alpha, you could copy depth, motion vectors, anything specific, whether anything at all, really. Any channel you can possibly think of, you can copy it from one node to another node. I would consider maybe using, I like using the shuffle node to copy things over from one node to another, but that's limited in only being able to use 2, right? So it's you would connect only to your A pipe in, and you can set this to be A. And I mean, you might be able to change it. I don't think you can. I've never added more than just the 2, right? So I've always been limited to what it is. But it's super handy dandy, because to copy the alpha in, you could just say, I would like to put my alpha into my B alpha. Right. So, and you could even just say, I want to mix and match my red, green, but leave the blue. You can do whatever your heart desires. But this is pretty much my setup for whenever I'm doing any type of roto. I'm setting my roto node to output an alpha. I'm using an erode node on just the alpha and a blur node on just the alpha to manipulate how much it's being pulled in, as well as the amount of the amount of feather that I'm applying to it. And that's allowing me to copy it over and then pre-molt it in, right? So now I have maximum control of seeing that this is my roto, and this is how I can bring in that roto or pull it out, as well as my feather. And I'm able to visually see that I am doing that process, which is something that is, you don't want to overlook that in Nuke. That is one of the many powers of actually being able to have this much precision and visually understand what is happening in your comp from the outside looking in. Just very quickly seeing like, oh, zoom in, I have a roto, oh, I applied an erode to it, oh, I had a blur to it. You know what, actually, I want to pull that in, I want to bring that out, I want to yada, yada, yada. You can very quickly on the fly manipulate these things and understand that it was a step of the process for your comp. So you're more aware of what it is you were doing, and it's almost like you're saving a log of, hey, you eroded or dilated your roto, or hey, you blurred or feathered your roto. And you're not having to like search within the node and make sure that you're on the right tab and click over and be like, oh yeah, okay, the feather's here, okay, this is over here, okay, I did. It's just a better way of working, in my opinion. But let's say you wanted to cut your roto from another alpha. Or maybe an alpha from an alpha. Let's say you were using a shadow catcher on a CG render and you're trying to combine that with live action plate photography. And let's just say you have overlapping shadows. You have your real world shadows and you have your CG shadows, and you need to find a way to blend between them. Well, in the real world, shadows don't overlap. If you have a perfect shadow that has complete darkness, you don't double up and have double the shadow because you're already completely in the dark. So, in order for this to make the most sense, you need to have control over in the center where it is completely dark. There is no overlap in shadow, but maybe around the edges of my real world live action shadow, there is a level of doubling up, and that is where my CG shadow can exist sometimes, but in reality it for the most part needs to exist outside of where my live action shadow is. So to be able to cut out your roto from another alpha, or your alpha from another alpha rather, you're going to use a channel merge node. And you can use the channel merge on different channels, right? You could channel merge any channel. You could channel merge your mist pass or your depth pass or your anything you can put your heart and mind to, you can channel merge it. And that is one of the superpowers of Nuke. It is like the alpha matte or luma matte inside of After Effects, just blown beyond belief, because you have more inputs that you can maximize and you can grab from any different pre-comp over there, over here, CG render there, CG render that. Being able to shuffle your channels and utilize them specifically where you need to is the biggest superpower that Nuke has to offer, in my opinion. I mean, data management through the roof, but this is one of those areas of expertise where it is showing you where it shines. So we add in a channel merge, and we add in another roto, making sure to output the alpha here as well. And the no clip thing isn't like the greatest practice, but as long as you're keeping an eye on your actual bounding box and making sure that it doesn't exceed past too far. Like, for example, if I just like drew out here, now we are creating a much bigger bounding box. So we would need to crop in, because that is 10,000 by 8,000 pixels, which will slow down your machine by quite a bit. So only do the no clip if you are being very mindful of your bounding box and cropping at the end of every stage possible, which is something that you should get in the habit of doing, because ultimately you should be pre-comping each branch going into your spine, aka your A pipe going into your B pipe. You want to pre-comp before going into your B pipe, at least if you can help it. Some operations are going to be lighter than other operations, so it's not always necessary. But as a general rule of thumb, you probably should be doing it. So let's just say here I wanted to add, I want this, like this shadow is my real world shadow, and this shadow is my CG shadow, right? Well, they would be overlapping one another in a way that isn't exactly realistic if you just have them being applied over and on top of one another. So you need to cut out one shadow from the other shadow. Now, the most common operations that I'm using inside my channel merge node are going to be union, max, in, from, and multiply. Sometimes I use stencil as well, but really it's in, from, and union. Those are just the top operations that I find myself using. If you do use max, you do need to make sure to clamp your alpha channels, because your alpha channel really should only exist between the range of values 0 to 1. Anything outside of 1, it's just, you're not going to be managing your alpha properly. It's 0 equals no image, 1 equals an image. Anything beyond or below that, you're going to have problems. You don't want negative values. You don't want over 1 values. Just 0 to 1. Super basic. Remember it. Cement it into your brain. This is just the way the cookie crumbles. If you don't know, now you know. So this is our CG shadow, and this is our real world shadow. And essentially what we would like to do is use a from operation to basically say that this CG shadow here can only exist where the real world shadow does not. So the A pipe being what the operation is taking into account, the B pipe being what the operation is being done to. So it kind of works exactly as you would think it would, where from is the alpha channel from the A pipe is being subtracted from the B pipe. And the in operation is also the same, right? The B pipe can only exist within the A pipe, right? So A pipe, B pipe, within the A pipe. From is more what we're going for here. But let's just imagine we were doing kind of what I was saying earlier, where I was talking about the edges being kind of more blurred out than not, right? So now it's kind of here how we can control that, so that way you do see some of it within, but not all of it. It's really just the core that is entirely blocking out your ability to see the CG shadow. So now you're getting this beautiful mix of sometimes you can see your CG shadow through through your real world shadow, but not all the time, because you don't want those to overlap, like I was saying, right? Now, there's also other circumstances where you're going to find this useful. So if we were to just read in just this CG render that I have here, set it to ACES CG because it's CG, you're going to notice that I have absolutely nothing coming in. That is because I rendered this out of Blender, and Blender's a little funky, so you actually have to shuffle out your combine channel. Some other renderers like Houdini will do it for you. Just so I only do one, I'm just going to pull up this left one. But in Blender, you do have to shuffle out your combine channel to show up where you would expect it to show up. Now, I'll do a little bit more of an in-depth understanding of crypto mats and all that good stuff, but assuming you already have a crypto mat coming out of Blender, you know how to do that. This is how you would actually work with that. So we are going to we're going to shuffle out our crypto mat, so that way you can actually access it inside the node. So just shuffling it into there, right? Now we have a beautiful selectable image on the crypto mat node, making sure we have the picker add-on. And we select what exactly we're trying to select. You could always select the scaffolding down here, or any other pass that you have within your crypto mat itself. Now this has created a new alpha, and let's just say for example purposes, we wanted to put a checkerboard on top of this billboard. So just making sure it's the exact same format, we'll drop down a corner pin node, and we will merge this using M and Y to connect them. Once again, Y, control selecting to access our dot node on the fly. Now we have this beautiful checkerboard just sitting right on top, using the corner pin to grab the edges, trying to very quickly make this look decent. But obviously when you're doing this for a real world task, you're going to want to make sure it looks perfect and it's lined up exactly how it should be. But not the most important thing for us to do right now. We're just getting the point across of the channel merge node, right? So now we have this alpha and this alpha, and we would like to subtract the scaffolding. So we need the channel merge to be within the B pipe, and we would like this alpha channel to exist within this alpha channel. So guess what operation we're going to use? You guessed it, we're going to be using the in operation, which has now successfully subtracted out our scaffolding. And ultimately, these look very similar. There is a slight little difference right here, but it's working exactly as expected. We are taking this alpha channel and this alpha channel, and we are subtracting, so that way the alpha channel of the corner pin checkerboard only exists within inside the alpha channel of the billboard itself. Now you'd need to throw a premal at the bottom of that, and that solidifies your mutations or manipulations to your data. So you have successfully subtracted out that from the billboard, and you can throw it on top and see that it is working exactly as you would expect it to. Now, one thing to note is that with CG, it is always going to come into your compositor already pre-multiplied. So if you would like to do color corrections on top of it, you are going to want to perform what is known as an unpremult premult workflow, which is essentially where you unpremultiply the edges, do your color corrections, and then pre-multiply them back into place. I don't exactly understand the math, but all I know is that it maintains a proper edge without having any unexpected variation within the color itself. So you're actually getting the result that you think you would, which is important in compositing, right? So just using the grade node, using G on my keyboard, and the color correct node using C, and maybe we'll type in hue shift, Usually you want to work within the HSV color space to do this type of thing for hue and saturation, but this is just an example. So we're gonna call it beautiful here. So we pumped up the saturation. We do a little bit of a hue rotation just because why not? And then yeah, we pre-mult the image at the very end here before it gets merged with our checkerboard. And if you wanted to do the same thing to your checkerboard, you would also do it before the pre-mult here as well. It's not really crucial to do the same unpremult pre-mult, but actually I think it would be. Yeah, it is. So I mean, like, it extends out that edge just a little bit further, which gives you the room to play and do some of these fun things. Like, let's just say um, we decide to just boost up the red, and now we decide that we actually want to hue shift it a bit to be something more that color, and then we use the saturation node to desaturate. This is kind of your general bread and butter for how you would actually make your color corrections and adjustments using a proper unpremult and premult workflow. If you've ever imported a file into DaVinci or After Effects and it came in without an alpha channel, that is the pre-multiplication happening for you ahead of time without you having to manage it. Now, the main issue with not being able to understand what pre-multiplication is and unpremultiplication is that you're going to get these interesting black borders from time to time, which I don't know if you've ever noticed, but I noticed personally a few years back when I didn't understand what this was, that I was unable to get a proper edge and I couldn't figure out what it was. And it was just not managing my multiplication on my alpha properly. So that's kind of really the bread and butter of it all. The copy channel node works great for copying your alpha channel over from one node to another, as well as any other channel you can think of. This can also be done within the shuffle node itself. And I highly recommend using the channel merge node to union multiple different channels into one, or multiple different alphas into one, or even just simply a couple different ones having to have an operation like from, in, or stencil. Maybe you're using union or multiply, remembering to clamp your alpha so that way it sits in the values of 0 to 1. It's all pretty crucial to getting your proper edge and making sure that you're maintaining consistency within everything here. Actually, okay, I changed my mind. I'm so sorry. You definitely don't need to unpremultiply this edge because it hasn't been premultiplied yet. So that's the difference, right? CG already been premultiplied. This checkerboard has not been premultiplied. So therefore, we did not need to do those adjustments because we don't need the edge to be extended. So if you're ever finding that your edges are doing weird things, just double check. Maybe deleting one of the premults or adding it back in is gonna fix the problem for you. You never know if you don't go. Just real quickly and briefly, when I'm using the merge node, I'm pretty much always using the over operation. A top does the same thing. I know that there's slightly different math happening behind what it's actually doing to your pixels. So I just leave it on over. The main ones that I find myself using are screen. Plus is honestly better than screen because screen is doing more to the image. So sometimes that can complicate things in a way that's undesirable. I use multiply and divide to divide out details and then multiply them back on top if I'm trying to, I don't know, let's say just add in like a face tattoo and I want some of those porous details of the skin back over. So over, multiply, divide, plus, screen, they're gonna be your main operations, but some of these are familiar, like soft lay and overlay and color dodge, color burn, all those good things. I will leave a link in the description to a list that shows you the math that is happening behind each operation, but they work exactly as you would expect them to. If you're familiar with any of these, then you kind of know what you're gonna get out of it. So that's been this video. I hope you've enjoyed it. If there's something that I can teach you within Nuke that you would like to understand better, be sure to leave a comment down below and I will do my best to get to it. Until next time, be sure to seize the day and keep learning. That's all we can do. So thank you so much for watching. This is only the beginning, and I will see you when I see you.